Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Gabriel Reed, a senior software engineer in the product engineering group of Tele, a major digital map provider. Gabriel has been working in the software development field for 7 years and has been using FME extensively for much of that time.
Okay, yeah, so I'm going to be talking about extending FME programmatically today. But first I'll just add a little bit to that introduction. I work for Tele. Some people here might be familiar with it already. It's a digital map and dynamic content provider. So we provide source data for personal navigation and in-car navigation systems, as well as mobile and internet map solutions. And our current database coverage is about 87 countries and just under 30 million kilometers of roads and 24 million POIs, and that's growing all the time. And I work at Tele as a software engineer in the product engineering group. So I write software for converting data from our internal formats into external product formats like GDF and Shape. So today I'm just going to be going through the main categories of programming interfaces in FME and giving a few examples and talking about some lessons that I've learned from working with them. So at a really high level, there are two main interfaces for programming with FME. You can extend FME's functionality with your own software, or you can extend your own software with FME functionality. So that second one, that's really the domain of FME objects. But I'm going to be focusing on extending functionality of FME. All of that also includes the use of FME objects. So when you're extending a functionality of FME, there are two main ways you can do it. One is extend within your workbench. So it's using Python or TCL. Or you can actually extend FME itself using a plugin SDK. And I'm going to be going into those a bit more in a little bit. So when would you want to extend functionality? In my experience, I've come up with 3 situations where that is worth doing. First of all, if you're doing something that's relatively simple or seems relatively simple, and using FME makes it complex, that's definitely a time when you want to think about using extensions. FME is really good at making very difficult problems into, or very good at giving simple solutions for very difficult problems sometimes. But every once in a while you get constrained by FME when you're trying to do something that seems simple and it just makes it a little bit more difficult than it should be. The second one is just when FME is too inefficient. If you have some kind of performance problem with FME, sometimes you can solve that by doing programming extensions. And the third is just if there's required functionality, if there's that you're missing. So if you just need to do something and FME can't do it. That happens less and less now with new releases of FME, but it still definitely can happen. But first of all, I think it's important to talk about why not to do it as well. I think this rule applies for pretty much any kind of software development. You don't want to do it unless you have a good reason to. And why not? Well, if you're adding code to FME, then you're potentially increasing complexity. Just because you are adding some extra logic possibly into your workbenches. Can be somewhat hidden sometimes in a Python caller or TCL caller. You might be decreasing maintainability because people who are going to work on your workbenches need to understand Python or TCL later on. And I think probably a lot of people here know what it's like even if you make a workbench, even just without using any programming in your workbench. Sometimes when you create your workbench and you go back to it 6 months later, it takes a while just to figure out what you were actually doing when you first wrote that workbench. And finally, you can potentially decrease compatibility if you're adding extensions to FME because you've got software versions to worry about. Or potentially have software versions to worry about. You may have to send or share extra files with your workbenches if you're sending workbenches around. So it's not just a case of emailing someone your workbench if you want them to let them use it. So it's like Uncle Ben said in Spider-Man, with great power comes great responsibility. And that's definitely the case here. So I'm just going to go into an example of reducing complexity with Python or TCL. So I've got a text file here, which can just be read using a text line reader in FME. And it's got a number of fixed width fields, which are all really easy to deal with in FME. But the one twist here is that there's a repeating fixed width field as well. So I've got an ID field, a feature class field, a coordinate count field, and then a set of coordinates. So these coordinates repeat a certain number of times. That's what the coordinate count field is there for. It's just x, y pairs of coordinates. And seems like I think, easy thing to figure out how you would figure out the geometry of these features. If you're just looking at this file, but actually getting it to work in FME is a bit more involved. If you're using just pure FME, so you start off just taking an attribute splitter here and an attribute renamer to split out those first three fields, the ID and the feature class and coordinate count. And then the hard part comes when you want to get those coordinates out of there, the repeating field, and add them to the feature. So I've got a custom transformer here that does that. And to me, if this has 8 transformers in it plus a loop, and I know just from the experience of putting this together, there was a lot of frustration involved in getting this working, and it's something, like I say, I mean, you can do really complex things with FME with almost no work, but getting something simple like this to work seemed a lot harder than it should be. So switching over to using Python to do the same thing. So I've replaced that custom transformer with a Python caller here. I'll just open that up. And so I've basically replaced that the custom transformer just with code here, which is just looping through the coordinates and adding them to the feature. And so here I've got, if you take away the comments, I think I've got about 10 lines of code. To me, this is definitely a lot easier to understand. If you just look at this, I think it's, if you know a bit about Python, it's pretty clear what's going on here in this code. This took definitely for me about a tenth the amount of time to get this working compared to the custom transformer. Another advantage here, I've got the coordinate size, so that's the size of the coordinate field, just put in one constant here at the top of the file. So it's easy to change if we do want to change the size of the coordinate field later. And just to keep TCL fans happy as well. Exactly the same thing can be done here using TCL, and it's the same kind of thing. It's just about 10 lines of code, and you're replacing that custom transformer. But just to take this example a little bit further, let's say you need to support files that are going to have different lengths of or different coordinates field widths. So you're going to have coordinate fields that are maybe have a workbench that supports coordinate fields that are 15 characters wide, and another one that or another workbench that supports coordinate fields that are 20 digits wide. Well, what you could do is just take that Python code, copy it, and put it into a new workbench, or paste it into a new workbench and just change that one constant. But if you're copying and pasting code, that's generally, or basically always in software development, a very bad thing to do, just because you're doubling your maintenance work in the future. So what you can do then, or definitely what I prefer to do in a situation like that, is actually just take your code and put in an external file. So a Python module. And then in your actual workbench, all you have here is just a little tiny bit of code that actually calls your external module. And one of the really big advantages to doing that is that you can then you can actually use automated testing or unit testing. I'm not sure if people here are familiar with that term, but it's a way that you can have automated testing to test the functionality of your code. And anyone who's spent time debugging Python code inside of FME, it works, but it can be pretty time consuming especially if you're waiting for a certain error condition in your data to come through. So that's where it really pays off to have your code externalized and just have use unit testing, and then you can sometimes write pretty complex code a lot quicker and not have to worry about the whole development loop within FME. So just walking away from that whole experience, definitely what I took away from doing that was, well, like I said before, you don't want to start adding code to your workbench unless it's really going to simplify things. And I think your mileage may vary. It depends on how experienced you are with writing Python or TCL. But definitely just that example there, in my experience, it was a lot easier doing that, displaying out those coordinates in Python. And if you start copying and pasting code, that's usually a sign that you want to put your code in an external module. Of course, I'm talking more about code that's 10 lines of code or more, not just one single line of code. I think that's fine to copy and paste that. And when you externalize your code or put it in an external module, it does make sharing your workspace more difficult, but it allows you much better testing, automated testing. So it's something you have to weigh up if you're looking at a situation like that. And just the setup of the Python path, I didn't really show that in the workbench there, but you can tell FME where to import your Python files from using a startup script. So that's the way I usually do it. If you want to have, for example, one central repository of Python files that you're going to work from. And before I mentioned increasing efficiency through writing extensions. Sometimes you know something about your data and you can't communicate it to FME. And so sometimes FME just kind of blindly looks at your data usually and just starts processing it without really realizing what's in your data. That's one of the great things about FME, but can also be a drawback sometimes. FME has, I know in some transformers, has some things built in to do automatic optimizations. Like in the spatial filter, I think, or spatial relator, you can tell it how many you can tell it if you only have one base feature to match against, or if all your base features are going to be going into the transformer first, and that allows FME to optimize a lot. Sometimes you can't give FME hints like that, and that's an experience that I came up with dealing with GDF ASCII relational data. So GDF ASCII relational, or GDF AR. It's not the same GDF that you hear people at SAFE always talking about, saying how bad it is, but it's the same kind of thing. It's basically it's like a relational database that's been dumped into tables. So it's one file, or dumped into files. Sorry. So it's like one text file per table, and it's just each text file just contains fixed width fields. So it's really easy to read in and parse in FME. But because it's like a relational database, you've got links between these different tables, and so just got a small example here with the point and the node table. So the point table contains POI information, and the node table contains coordinate information. So the point table doesn't actually contain any coordinates, so you have to link to the node table using a foreign key. So using a node item ID to link to the node table to get the coordinates for the point records. Now you can, I'll just show that. So that's what the file basically, or what one of the files basically looks like. I think that's the point file there. So if you do want to read the point and node tables in and join them up, it's, conceptually very, very easy to do. Basically, just read in both the point and node tables, split out the fixed width fields with an attribute splitter and attribute renamer there, all very simple, and then just send them through to a feature merger to merge the node and point records, and a 2D point adder here, and you've got the coordinates are added to your point records. And that all works fine, except the performance is quite poor because FME has to read the whole, both files completely into memory before it can start doing anything with the feature merger. And an important piece of information I didn't mention before is that the data is sorted and grouped based on dataset and section information in these files. So it's kind of like spatial partitions. The data is spatially partitioned, so all data, all records for a certain partition are grouped together. So what you can do is just read in one partition's worth of point records, one partition's worth of node records, and merge them together and then send them through. So to do that, you have to replace the workbench I was just showing with a bit of Python code, and that's what I did. I created an external GDFAR reading module to do that, and as well unit tested. Well, I wrote that using unit testing, so it was able to test it and actually develop it quite quickly. Although it is a bit of work writing an actual reader in Python to do that, but it definitely paid off in terms of performance. So using a pure FME solution on the dataset of Northern Ireland, it took just over an hour to process the point and node records. And using the FME Python combination took under 2 minutes for the same data. And considering that's only 2 tables out of data sets that contain 46 tables in reality, it wouldn't be workable to use pure FME for the whole data set. And then, yeah, just going back to lessons learned from that, obviously knowing some rules about your data can make a huge difference in performance, but obviously you want to have a performance problem to deal with before you start replacing things in FME with code. And again, definitely in this situation, I really tried to keep the GDFAR reading code separate from any FME logic. So there's nothing related to FME in the code that's actually reading in the GDFAR records. And that allows you to use unit testing really well, and just allows you to use that if you want to use that code for something else later that isn't related to FME, then that's no problem. So you just have to create a small software layer between your reader and FME to actually convert your GDFAR records into FME features, but that's actually pretty minor work. And startup and shutdown scripts, I think probably a lot of people here are probably already familiar with them. You can do pretty much everything you want with them. The one thing I was using them for in all the examples here is setting up a Python path variable, so you can tell FME where to import your Python files from if you are using external files. But it's great for zipping files after you create them, or checking input data structures or output data structures before you even start processing. And moving on to the plugin SDK, so this is a way of actually adding functionality to FME. So creating functions or factories or readers or writers. Anyone who's actually worked with mapping files will know what functions and factories are all about probably, but they're really the kind of the life and blood behind transformers and workbench. So that's what's actually being used to do everything in FME. So when you're working with the plugin SDK, you have more access to the inner workings of FME, but you have to work in Java or C++, so it's definitely more involved, or usually more involved than working with Python or TCL inside of Workbench. But on the other side, you do have more power with it. Definitely the golden rule of writing extensions definitely counts double here, because you are adding a whole bunch of complexity when you start working with the plugin SDK. So you really want to be sure that you have a good reason to do it before you start doing it, although it is pretty fun to work with as well, if you're into that kind of thing. And yeah, once again, I was really trying to keep a clear layer between FME-specific code and generic code, so definitely write your functionality, the actual functionality you're trying to create, if possible, create it without having anything to do with FME in it, and then worry about linking it up to FME. Just going to go into creating a function. So a function basically processes one feature at a time. Functions get used a lot behind the scenes in the FME Workbench. And creating a function is definitely the most simple thing you can do with in the plugin SDK. It's basically you just have to implement the IFME function interface that's defined in the SDK, compile your code, and stick it in the plugins directory. And you can actually create a transformer over it as well if you create an FMX file, which I won't get into now. But this FMX file is just basically the mapping that describes transformers in FME. So just as an example here, I wanted to create add SoundEx functionality to FME. So SoundEx is kind of like an encoded value for the sound of a word or a string. I think that it's available in Oracle, I think. It's definitely not in FME, as far as I know. But there's also an open source Java library that implements the SoundEx algorithm. And so actually to add that into FME as a function, this is basically all the Java code that it took. So this is definitely the most simple example of using a plugin SDK that I've ever had, but basically comes down to this, just creating a SoundEx object and encoding an attribute value and sending it back out. So based on this, you can actually create a SoundEx transformer in FME. And then moving on to factories. Factories are a lot more closely linked with what everyone, or the way everyone knows transformers in FME. So factories can take in, or can have input ports for features and output ports, and so you can do basically whatever you want with factories. You can create new features, throw away features, change features, do whatever you want. And so just create a kind of a fun example of something you could do with, well, yeah, fun is a relative term, I guess, but kind of a cool example of doing something. You hear FME described as a visual programming language quite a bit. And so something that's maybe kind of missing from the visual programming language is a debugger. And if you do run into problems sometimes with FME, you can use the logger if you want to debug things that are coming through FME. But yeah, I'm not too crazy about the logger because it doesn't actually pass features through it. It's a dead end. So if you want to actually see features as they're going through your workbench, this will probably just be easiest if I just show it. So I'm reading in water features from Belgium, sending them through a debugger, and then through a central line replacer, and through a second debugger. And I'll just start this up. Now, starting up workbenches, if you've got a Java plugin in there, takes a little bit longer. But hopefully it won't take too long. Okay, so I've got here, these are actually the features as they're going through that transformer in real time. And like I said, it wouldn't be much of a debugger if you couldn't pause it. So you can actually just pause it and actually step through your features one at a time and inspect the attribute values. And it's got the well-known text representation of each of the features as well. And I'll just close this. And then you can continue back to get it running through again. You can actually change the delay per feature, so you can let it run through really quickly or slow it down as well. I've actually created a breakpoint transformer as well for this. So you can just set a condition and it'll run through until it reaches that condition, so until it finds a feature with a certain ID, for example, and then stop the translation and open up your debugger window. And then readers and writers, in my experience, definitely the most complex thing you can do with the plugin SDK. This is one, I'll make a plug for professional services from Safe Software here, because I know I've definitely had a lot of headaches creating readers and writers. There are a lot of things you have to worry about, setting up your schema features and data type mappings and geometry type mappings, and it's something that actually isn't that well documented yet. So it's pretty involved, although if you do have a format that isn't supported by FME, then that's usually the way to do it, although you can use a Python creator in FME as well. And once again, yeah, I'd definitely try to get your functionality working first without paying any attention to FME if you're creating a reader or writer, and then worry about linking up to FME. It really pays off in the long run as far as your testability of your code. So just to wrap it up, like I said, I really recommend only using extensions unless they have a real added value for your for your situation. And I always look for the balance between the most simple and most testable solution. And yeah, I've said it a few times, try to keep FME specific details out of your code as much as possible, just to keep things generic. And I think if there is useful functionality that you're adding to FME, it's definitely worth letting Safe Software know about it, because they might want to add it to a future release of FME. And that's about it.